So in this video, we're going to talk about an exception handling technique called the try-catch block. But before we get started with how to write the try-catch block, let's revisit what happens when an exception occurs in our console application that does not have exception handling. So take a look at the example I've written here with a numerator, and I've predefined that to 7, and a denominator that I've predefined to 0. We do the division operation, numerator over denominator, and put that into result, which is then printed out for the user. Now everything here goes fine as long as these values are actually values that we can multiply, or I'm sorry, values we can divide by. So in this case, 5 over 10 should give us the value of 0 because it's evenly divisible, right? But what if our denominator is 0? Well, we can't divide by 0, and that causes an exception. And here's where it's really important about the difference between debugging and running our programs without debugging. So if I run this without debugging, I can see that I get an unhandled exception in the console window. Windows tells me that my program has stopped. I can jump in and debug, and it will actually help me out and take me into Visual Studio. But I can review and see that a system divide by 0 exception attempted to divide by 0 was caught by the .NET framework system in your compiler, but it didn't know what to do with any of that, so it just crashed. Whereas if we run with debugging, when the program crashes, you'll actually be taken directly into Visual Studio, and the offending line where the exception is occurring will be highlighted and more information about the exception will be given. So that's one of the really basic differences between running the application with and without debugging. So let's review the statement called try catch. So the try block is the section of the code where we want our execution to take place. So you define the try block to enclose the code that might throw exceptions, as well as code that may be skipped if an exception occurs. So in this case, since it's the mathematical operation that may cause the ultimate exception, we put it inside of the try, and then we don't want to try to print anything if an exception occurs, so we go ahead and add our write line into the try as well. The catch block allows you to define either the generic exception class, like I've done in this case, or a more specific exception, like the one that handles a divide by 0, and then do something more appropriate, such as display a specific error message or do any kind of processing needed, call other methods or anything your program needs to do in the event of an exception. So now we can run our program and see what this looks like. So instead of getting that ugly exception divide by 0 problem, we just see an exception occurred, which is the statement that I have the catch block writing out. So when we're debugging our application, we can see what happens as we step through the code. Once an exception is triggered, you'll be popped down into the catch block, and more information about the exception will be available here in the exception helper menu. So sometimes there are some troubleshooting tips or some detail information that you can get about this particular exception to help you when you're debugging your applications. So to reiterate, all of the code that we want to essentially try or that may cause an exception goes in the try block. All of the exception handling code goes in the catch block. So when an exception occurs inside of the try, the catch block catches it, handles it, and then allows a more graceful execution of the program.